Today we are going to be using the app called Explain Everything, and we will be using it to look at the app called Chemistry. This is an educational app that you can use in your chemistry classroom. So as you can see in this app, we've got 5 different sections that we can use. The first one is called Reactions, down here. Then we've got Table, Solubility, molar mass, and schemes. All of these are important aspects to the chemistry classroom, and a student that is taking chemistry can use all of these different tabs to do different things in class. So this first one's called reactions. For this section, you will type in a chemical, a molecule, an element, anything up into the search bar, and you're going to get a whole list of different reactions that contain this element. So the more you type in, the more narrow your search is going to be. I typed in CH4. That is a simple carbon bond. And right here, circled, you can see a combustion reaction. A good example of this would be in your car. A combustion reaction occurs when you put your foot on the gas, puts gas into the engine, burns that, produces CO2. So if I was looking for a combustion reaction, if I know CH4 is in the reaction, I can type this in at the top, and then I can look for my reaction from here. Next is the periodic table section of the app. This is really helpful for chemistry students because the periodic table is your main source of information. So as you can see, the table that they give you in this app contains a lot of useful information. If you look at number 2, helium, up here at the top, you can see that it gives you its atomic number 2. It gives you the abbreviation of the element He, which you'll see a lot of times when you're doing chemical problems. They won't tell you helium, they'll give you the abbreviation instead. And then it gives you the atomic mass at the bottom. And these are useful in chemical reactions because there's a lot of times when you're doing a question on a test or quiz or some homework that you'll need to know the molar mass of a atom. So next we're going to look, it's an interactive periodic table, which means that you can click on the different elements, and for this one we're going to look at bismuth down here. That's my favorite element. So this is the page that pops up when you press on an element. It takes you directly to the source of the Wikipedia page. So it'll give you the name of the element, it'll show you some pictures of the element, and if you scroll down it'll give you more useful information about it and lots of information over here on the left. Next is the solubility tab. This isn't so much for tests and homework, but more for when you're doing work in the lab. So you'll see and use this a lot of times in your higher level chemistry classes like organic chemistry, chemical analysis, harder labs, and stuff like that. All these numbers mean different things. The key here at the bottom will tell us. So the blue talks about solubility in water, insolubility in water, decomposing in water, few solubilities in water, and then no data and no information. But basically this chart is useful for when you're doing a lot of chemical reactions, making chemical solutions. You want to know how these different elements and molecules are going to interact with each other and interact with water when you're mixing them together. Next is the molar mass calculator. This is a really useful tool because a lot of times you've got these really big equations that have multiple elements in them, and so you'll have something like a benzene, which is 6 carbons and 6 hydrogens, and you're trying to find the mass of that, but you don't want to type in your calculator the mass for 1 hydrogen plus 1 hydrogen plus 1 hydrogen all the way up to 6 hydrogens, and then you'll be adding that to 6 carbons. And by the time you do that and you type it in your calculator, that is a really long process. So what you want to do, let me erase that real quick. That's good enough. We'll use a different color now. Alright, so for instance, I'm going to look at sulfur hexafluoride. Alright, so you'll be adding 1s plus 6 fluorides. Now what you could do is you could go back to your periodic table and you could look up the mass of 1s and the mass of 1f, and you could add those one by one into the calculator. Instead, this tab allows you to just type it into the top up here, and then it'll give you all your information down here. So you don't have to go through the calculations, the app will do that for you. The last tab you see is called Schemes. Now this is going to give us 3 different charts that will help us out in chemistry, whether it be in the lab or doing some chemistry problems. So the first one we're going to look at will be molecular weight of an organic substance. The next chart is molecular weight of organic substances. So this one we're going to use a lot in organic chemistry. There's a lot of common bonds that happen between different radicals and functional groups, and so this chart just gives us combinations of these and then allows us to find their weight super easy. So for instance, we can look at what would happen if we bound a propyl group with a bromide group. And so we would go down the bromide column until we hit the propyl column, and then right there at the 123, that would be the molecular weight of propyl bromide. Another one we could do is we could look at the ethyl group and see what would happen if we bound it to a chloride group. And so we would go down the chloride column until we got to the ethyl row, and that would be 65. That would be our molecular weight for a ethyl chloride. And that just gives us an easy way to figure out that molecular weight without, again, trying to go and use a calculator and figure it all out on our own. The next one is reactivity series. Basically, reactivity series shows us if we have a bunch of elements, which ones are going to react first. So this one's helpful when you are doing lots of different homeworks or talking about situations where multiple elements are exposed together, knowing which ones are going to react first and which ones are going to react the fastest. And like it shows, this is a really long list that goes down, so this kind of lays it out for you so you don't have to memorize this. It gives you a sheet to look at and be able to refer to when you're doing these problems. A lot of times teachers will give you this anyway, not make you memorize this. Lastly, we have the electronegativity of elements. This one just shows us the different values of electronegativity of each element. The electronegativity is basically the strength of the charge on the electrons of the nucleus of an atom. And so we see a trend as you move up the groups in the periodic table, you're going to see stronger electronegativity. And as you move across the periodic table, you're also going to see an increase. And this will just give us the specific values of these. It helps to know these values when you're looking at a reaction. So if you have an H2O, that's water. You can look at this chart, and we're not scrolled far enough down where we can see the H and the O value on this. But what we would see if we did scroll down is that O would have a much higher value than H, which means it would be more electronegative. So we'll put a negative sign there. If the electrons are pulled more towards the O, this way, and this way, we would see these values becoming positive up here, which is why when we have water, it beads up, because the negative on one H2O is going to attract to the positives of another H2O. This positive is going to want to stick to this negative, which is why water beads up and always wants to run. Like if you're pouring a glass, sometimes water won't go straight out of the glass. It'll want to run and stick down to the side of the glass, and all the water will want to stick together. That's why it does it. And so using this chart will just help you to know when you are reacting different molecules together where the electrons will generally tend to be.